Hello, welcome to another Midnight Maths video. In this one, we're going to talk about more trig transformations. Yay! So we're dealing with things like sine 3t in this video. What does sine 3t, how does it compare to sine t, all of that business. And we're going to look at it primarily in the unit circle representation, which is going to be really cool and intuitive. And I think it's a nice addition, supplement to the graphs that you always see in trig class. So here, let's sort of introduce you to this simulation we've got here. So this is actually a Desmos simulation. I will link the Desmos link in the description if you guys want to play around with it yourself. So we've got x-axis in white, and this white arrow is indicating the positive direction of the x-axis. So we're saying, okay, x increases this way, and y also increases upward, right? So that's what this green arrow is saying. You got your labels, right? 0, the origin is labeled twice, and then you've got this purple circle here, is just a unit circle. You've got this cosine function. So this is the main cosine function. So this whole unit circle thing, it's a unit circle representation of this cosine function, 1 cosine 1t, or just cosine t. And so here it's saying equals 0.54. Well, it doesn't always equal 0.54. It's just that at t equals 1, which is right here, this orange, t equals 1. If you plug in 1 cosine 1 times 1, you will get 0.54. So this is the main line, the main rotating line that we talked about in the last video. And then this projection on the x-axis right here, this guy, is going to represent the cosine, as mentioned in the previous video, where we project this rotating line on the x-axis, and then that will give us a cosine value. So I'll go ahead, sort of just play this. So this is really just a moving version of what I described in a previous video. So now with this out of the way, we can talk about, changing it up. So what I'm going to do is we actually have another unit circle sort of overlaid on this one. So here we've sort of changed it up a little bit. So we have a purple, just like we did previously. We also have a blue. So this blue is another line, and it's another function. So the blue line, as you'll see the blue line in a sec, but the blue line will represent the 1 cosine 1t, and the purple one will represent the 1 cosine 2t. So let's go ahead and let this spin a little bit, and you can see sort of what's going on here. And let me put it, so here we've got some sort of freeze frame at t equals 2. So let's sort of stop and look at this. So 1 cosine 1t, you notice that this line is at 1 radian, right, from the x-axis, because you go cosine 1 times 1, so you take cosine of whatever's in the parentheses, right? So if it's cosine 55 degrees, you rotate the line 55 degrees and then project onto the x-axis, and then now you've got your cosine. Or if you want, project on the y-axis for the sine, right? And then you notice the purple line is farther off, right? It's actually 2 radians rotated from the positive x-axis, because you go 2 times 1. And even though the purple line is further off, you notice that its value is actually, the cosine value ends up being numerically less, because we got flipped over to the other side of the x-axis, and there's just less of it, because you can see you've got a 0.54, like this horizontal blue line is actually longer than the purple one, because there's just less of the purple on the x-axis. So before I play the whole thing, I do want to allow you guys to pause and think about like how these two, as these two rotating lines sort of go along the same unit circle, what are some patterns that you think we'll notice? So let's go ahead, let's see what happens. So we are getting a little bit of lag, but you can see now. I want you to notice some things, okay? So first of all, by the time the blue line completes a rotation, you notice the purple line is actually done too, right? And moreover, if we just sort of wait for it, so here, as soon as the blue line reaches halfway, right there, right, almost right there, you can see the purple is coming over to finish a single rotation. So while this guy only half rotation, the blue one, the purple one's already a full rotation. And then you keep going, right? So you keep going, and now the blue one's going to get a full rotation, and now the purple one is coming in for its second rotation. So basically, the purple rotating line is twice as fast because you've got a cosine 2t instead of a cosine 1t. So what does that mean for the period? Well, you know that whenever you spin a line around this circle fully, it's just gonna like you keep on spinning it at the same speed, then it's just gonna follow the same motion, right? So really, what we're graphing here. Let me turn on the graphs because those can be more familiar, right? So we'll go ahead. Let's turn these on. And you can see, so what are these graphs really showing us is they're showing us the sort of signed length of these lines, right? The dotted lines along the x-axis, right? Let me maybe turn these off. And so basically, since in the purple case, purple one's spinning twice as fast. So that means it's going to take half as much time to go around a full circle, because full circle means period. So, of course, right, the period decreases by a factor of 2, while, of course, the period of this blue one is just going to be 2 pi, then the period of this purple one will be pi. So you can take a look here. Let's sort of go away, and we'll see, so pi to 2 pi, right? Pi to 2 pi for the purple one is going to be a period, so yeah. And then over here, you got to zoom out a little bit, right? So let me put these points to see. So you can see these points kind of clearly labeled. You've got, so you've got pi, and then this blue guy, he goes up and then down, and then he repeats himself starting right here. So this is pi all the way to 3 pi. So now you've got, right, 2 pi. So exactly what we were saying earlier. So basically, the upshot, right, is cosine 2t means you're spinning twice as fast. But of course, that does not mean that the value of the cosine is more, because you're still constrained within the same unit circle. So you cannot go more than 1, for example. There's no value bigger than 1, even if you put a 2t in there, because you're changing the angle. You're not changing the circle itself.